try this again. Now, as I go along, try to pause the video and do these next couple problems on your own. So it says, Tamara wants to know the width of the pond at the park. So that's our goal, the width of the pond at the park. She drew the diagram and labeled it with the measurements she made. How wide is the pond? So that's the question. So let's take a look at this pond here. Oh, they put a question mark on it. We're looking for this width of the pond, right? And those of you who are wondering, where are the two triangles I need to compare? Well, there's the width of the pond on the big triangle. If you're not sure, there's the width of the pond on the small triangle. And then the bottom of the large triangle is right there. The bottom of the small triangle is right there. If you're really struggling with that, I mean, honestly, just draw it. It doesn't even have to be a good drawing. Let's see here. That was a question mark, and the bottom was a 36. That was a right angle. And then we have this, and the bottom was a 9, and the diagonal was a 15, right? I just redrew that super duper quick, and I think it's a little easier to see something is going on. I think this would be a good one to do scale factor with. This might be a good time to pause the video to try and do this on your own. All right, so I need to go from 15 to question mark, the width of our pond, right? Then I need to find the scale factor of 9 going to 36. What am I multiplying by? What's that proportion? All right, 9 times, I know this because I've got a calculator and I'm also okay with multiplication. 9 times 4. If you don't like that, you could always do where you end over where you start. So that is 36 over 9 is how you get 4. 36 divided by 9 gives you 4. So that means my big triangle is 4 times as big as my small one. So that diagonal should be 4 times as big. So 15 times 4, let's see, that should be 60. You can check for me if you'd like. 15 times 4. Yes, it is 60. So that means the width of my pond is 60 yards. Because remember, they're measuring in yards right there on the pond. 60 yards. All right. Let's go to the next one. It says use the diagram for 2 and 3. So we've got these 3 pictures for 2 and 3. The first thing I'm going to do is that I see these 3 pictures, I'm going to make them triangles because that's the only way I know how to do things, right? That's a small one in the middle. Don't worry, it'll be fine. And there we go. Maybe make it more obvious that that's a triangle. Okay. It says how tall is the flagpole? Okay, well, which triangle should I compare it to? A, B, or C? I'm not sure. I know I need the flagpole, but is B going to help? I don't think so because I don't know how tall that thing is. So I think I need to use C, right? Let's use C. So if you look at A, and you know you need to find the flagpole, let's just say the flagpole is F, right? That's the flagpole. I know I'm comparing it to the height of the tree. But then I need to also compare their shadows, right? So at this point in time, I'm going to switch to ratios and see if we can try it that way. You could use scale factor, but I'm going to use ratios. All right, so I need to know, the ratio of the flagpole to its shadow. But since these shapes are similar, I know that ratio is going to be the same thing as the height of the tree to its shadow, right? Height over shadow, height over shadow. Does that make sense? All right. So that means I can cross multiply. And if you'd like, pause the video, see if you can get this one on your own. All right. So we have 119F is equal to 84 times 51. I'm going to use a calculator. 84 times 51. No, 84 times 51. 4284. 4284. I haven't found F yet because there's a number next to it, so I must divide that. Let's divide that. 119. So that means my flagpole must be 36, and then let's see. That is in feet. 36 feet tall. Some flagpoles, like at military or public facilities, are actually that tall. I had some comments in other classes that commented on that. Yes, they can be that tall. All right. Next question says, how tall is the child? A lot of people ask, where's this child? It's very, very tiny, because if it's a 36-foot flagpole, obviously a child's going to be smaller. So we need this child right there. We need their height. You can compare it, now that you know the flagpole is 36 feet tall, you can compare it to either one of these. I'll compare it over here. Now, if you want to do ratios again, we can. So let's see here. I need to compare the height of the child to its shadow. And then I need to compare the height of the tree to its shadow. And yes, shadows are going to be larger than your height. I don't know if you've ever looked at yourself in the sun, but sometimes, depending on where you're standing, your shadow gets super stretched. Check it out. So then we cross multiply, and then pause the video, see if you can get it from here. All right, 119, C, is equal to 51 times 7. So 1 times 7 is 7. 7 times 5 is 35. Feel free to fact check me if you're not sure about my mental math, but I'm pretty sure I'm right. All right, now C is not by itself, so we need to divide by it, by the number. So 357 divided by 119. So the child is 3 feet tall. Believe it or not, you were once 3 feet tall. That was probably a toddler. All right, let's see here. You might want to take a little stretch break at this point. We did do it quite a bit. If you feel confident, go ahead and